Okay, thank you, Lynn, for the introduction. I would like to talk to you about Xenographics and also about William Playfair because he has something to say about Xenographics. But I'm going to start off with a little anecdote. So in 1996, the English got to organize the European Championship of Football, and them being the inventors of the game, they adopted the slogan, "Football comes home." And it was a bit of a bold move. I would have been a little more modest, because when you organize a big football tournament, there's a big chance that this happens. So the Germans won it, and so the Germans took home the cup that was coming home. So the English, I think, should have chosen a slogan that was a little less bold. I consider OpenVis to be like the World Championship of DataVis, so I'm very delighted to be invited here on stage and share some of my ideas with you. But I think the organizers missed an opportunity to put a nice slogan underneath the very nice logo here. So I think the slogan here should be "Viz comes home." Because a lot of the DataVis pioneering work was done here in France and in Paris. So I think this is a very suitable slogan for this conference. One of those pioneers was Charles-Joseph Minard. He pioneered the representation of numbers on maps. So you can see here a map of how different kinds of cattle, animals and meat were transported by rail to Paris. It's a very nice map, and it's also a good metaphor of how all the data visualization cattle that is concentrated in this room flew in from all kinds of directions, I think. And then there's, of course, William Playfair. Are there any people here who have never heard of William Playfair? I see some hands going up. That's very good. So William Playfair was a Scottish engineer, and he's basically the founder of data visualization because he's the inventor of the bar chart, the line chart, and the pie chart. And he also lived a big part of his life here in Paris. So that's another link between DataVis and Paris. By the way, if you do a Google search for William Playfair, you find this man. But it's actually not the William Playfair. It's his nephew. He has the same name, but it's not the inventor of data visualization. So what you could do here in Paris is take a walk along the Seine, and in a little over an hour you are at the Rue de Petit Champ, and that's where Playfair used to live, and where he watched the French Revolution take place, and he also even participated in the French Revolution. So this is a quote from the book from 1786, The Political and Commercial Atlas. It's the first paragraph of the book. Oh, sorry, this is of course not by that one. And the quote is saying that Playfair saw that it wasn't enough to publish just data in tables anymore. There were more data, different kinds of data, and the world needed something new to communicate the data, and that's his reasoning for experimenting, and that's how we got to invent all these data visualization types. And the main point of my talk is that I think that we today, like Playfair in his days, are also living in a time where we have data at hand that's fundamentally different than what we had before, and that we also should be using new kinds of data visualizations to visualize these new kinds of data we have today. And what we need are what I call xenographics. So xenos stems from the Greek, is the Greek word for stranger. So xenographics are strange graphics, weird graphics. And one definition could be that xenographics are graphics that people haven't seen before. When Playfair published his line chart, bar chart, and pie chart, those were, of course, xenographics to the whole world. No one had ever seen anything like that. And so that's why I think that Playfair has some useful things to say about weird graphics. So I'm not an academic, so I can invent words without giving good definitions. And an alternative definition for xenographics could be that xenographics are what is published on xeno.graphics. And this is my hobby research project. It's like a gallery of all the weird charts and visualizations I could find. My criteria are very subjective, so these are things that I didn't see before, things that I think are a little underused or might be effective in some cases. I also tagged all the visualizations, so if you click on any of these, you find a description and a link to the source. And I'm also started a series of articles, but there's only one there at the moment. But I plan to expand the series of articles. So I hope this can be a source of inspiration for some of you. And it's also meant to be a catalog for myself, but I publish it online so anyone can consult it. So I hope that I can spread the word about this weird graphics, because I really believe that in some cases they can be really effective. So in the rest of my talk, I'll show some of these examples, and I also will share with you some insights I got from collecting these xenographics. And I grouped them. I tried to categorize the xenographics, and so the first category is only mildly weird, so they get 1 star, and then we get to the really weird ones in the end, the 5-star xenographics. And the first category has to do with how we consume information today. We used to have wide screens, big screens. Now a lot of us consume information on small vertical screens. And this obviously has consequences for the graphics we produce or the graphics we should produce. So this is one by the FT. It's your standard parliamentary composition visualization. But if you put it on a small screen with a vertical layout, then you run into trouble. The text becomes unreadable. You don't have much space for labels anymore. So what the people of the Financial Times did was rotating the charts when you read it on a small screen. And then once again, you still have a lot of space for putting labels and telling your story with the chart. The New York Times did the same with a map. So if you want to tell a story about something that stretches for long distances from east to west, then you also run into trouble on smaller screens. So they also rotated the map, and on smaller screens, the north is to the left and not up anymore. So nice solution. It upset a lot of people as well. Another example by the Financial Times. Here you have time running from top to bottom instead of from left to right. It also is using a logarithmic X scale, so I think this is a 1.5 star xenographic. This is the whole piece, and as you can see, this would be very difficult to put in a vertical layout, a horizontal layout, so it makes total sense to rotate the chart. So the first xenographic method is to flip axis or rotate your chart. And this was actually the topic of a panel at NICAR. NICAR is a big data journalism conference in the US. And these people, they discussed exactly that, how the use of small screens and vertical screens is affecting or should affect the graphics we make. And their main conclusion was, well, everything is a convention. How we orient our map or how we choose our axis is a convention, and we can conventions can be relearned, so you can break these conventions if necessary. But of course, this comes at a cost. Conventions are there for a reason. They are an entry point for people to get into a chart. It can be relearned, but it comes at a cost. So the benefits should outweigh the costs. But I think in a lot of cases on smaller vertical screens, it makes sense to use this technique. Okay, let's step up the weirdness a little bit. Now, the second technique is used to put more data into the same space, or to put the same amount of data into a smaller space. And this is a technique called piled bars. So what the author did was chopping up the categorical y-axis and then stacking the bars on top of each other. So this allows for more data to be visualized in the same space. Of course, when you have a lot of bars that have the same length, then you will run into trouble. Then you have too much overlap and there is no room for labels anymore. This is a chart by Gregor Eich from DataWrapper, present here. And he used the same technique for a long time series. So he had time series of almost 60 years, I think. And he just chopped up the X scale and then stacked all the decades on top of each other. So it's basically the same technique. I think it's a very good technique, but once again, it depends on the data you have. Because if you would make this with a data set that would result in a lot of crossing lines, then it will become really messy. And then there is, of course, the horizon chart that's using also this technique. So this is an animation by Frederik Ruijs from the Netherlands, which explains very well how horizon charts work. So you divide the y-axis into ranges, you flip the negative values, and then you stack the ranges on top of each other. So the second technique is break and stack scales. You break an axis, and then you just put all the different pieces of your visualization on top of each other. This is actually the page that Frederik published in the newspaper 10 years ago, the reason for him to make this animation. And it makes me a bit pessimistic that this was made 10 years ago and horizon charts are still so rare, because I think they can be even very effective. Research has shown that they can be effective, and still they are very rare. And I think this has to do with a conservative reflex that a lot of people have, and I call this xenographobia. So this is the fear of weird charts, and a lot of people suffer from this. So when they are confronted with a chart they haven't seen before, they run away. They don't make an effort to try to understand the chart. And especially editors in newsrooms, they are very xenographic. In some cases, the visual people in the newsroom, they make some interesting charts that tell the story really well, but then the editors say, well, very nice, but our readers won't understand. Can you please just make a bar chart? And I think this is a problem, because this leads to the xenographic catch-22, where we have a public that has a low level of graphicacy, that doesn't know how to read these interesting visualizations, and we have publishers not willing to publish more complicated charts because the level of graphicacy in the audience is so low. So I think we need to break away from this. We need to publish weirder charts. They need to be effective, of course, but I think we need to experiment a little more, and as long as we can explain how to read the chart, people will get it. So this is, yeah, I think we should publish more of these weird charts. And this is Playfair again, and he already knew that because, yeah, he was publishing obviously things people haven't seen before, but he was convinced that with reading a few lines of directions, all the difficulty in understanding this new visualization would entirely vanish. Okay, 3 stars. And here I'm going to start off with a quote by Elijah Meeks from Netflix. And he is saying with this quote that there is value in combining different visualizations together. If you have 2 views of the same data, or if you have 2 charts from related data sets, this can be very powerful. This has a lot of value. But in order to produce xenographics, you need to go one step further, and instead of marrying 2 visualizations together, you have to fuse them. And this leads to things like this. So this is a scatter plot of line charts. It's made by people from the New York Times. It might be one of my favorite charts ever made. So what they did is produce small multiple lines and then arrange the small multiples according to another coordinate system. So there's almost 70,000 data points in here, and it still managed to communicate something. So it's an interactive piece. I invite you to check it out. Then I was wondering, well, somebody must have made a scatter plot of pie charts, and somebody did. It was Andy Cotgreve from Tableau. What he should have done was, of course, do it this way. This is a scatter plot of bar charts. So this is the first technique for fusing data visualizations. It's just making small multiples and then encode information into the placement of these small multiples. But you can fuse data visualizations in another way as well. So this is, as you can see here, a tree map of bar charts. These are bar charts of tree maps, sorry. They are connected, so you can explore a little bit. I'm not sure if they're really helpful or useful, but I like them nonetheless. And this is a two-way street, because you also have a tree map of bars. It's not really a tree map because there's no hierarchy in here, but this is a technique called peg bars, invented and developed by Xenographics, who is also present here. He did an excellent job of building a website for his new visualization. And there's also a video explaining how you can make these things. There's also code if you want to make these peg bars. He also explains in what case you can use it, with what kind of data, and in what cases you will not be able to use this technique. And there are others like the Spark bar chart. So you have a line chart within a bar. And then you have the crossing between a line chart and a gouge. Jorge Camões, the inventor of this chart, called it the drunken speedometer. And he says of this chart that it's the most dangerous chart alive. So three-star method is crossbreeding data visualization types. And I think this is a good moment to talk about how we name our charts. And this is a quote by Michael Friendly, who has an excellent series of papers researching the history of certain data visualization types. And he's saying that nomenclature, so the giving names to things, is an important marker for the adoption and the use of innovation. And I think in data visualization, we have a problem when it comes to this. And take, for example, this animal, the Marimekko or mosaic chart. It has 3 names here. There are even more names for this type of visualization. And this is a problem because the knowledge about this chart is split up into different silos. If you want to know more about this chart, if you want to make something like this, and you Google Marimekko, you get only the hits from that part of the knowledge. About the chart. So you have to know that there are other names for this in order to get more information of this visualization. So the multiple naming of chart types leads to the siloing of the knowledge about these chart types. So what we should do is harmonize the graphonyms. So the graphonyms are the names of chart types. If we can all agree that this visualization is called like this, and then we can move forward, and then we can also more easily spread the word about these visualizations, and in that way we can advance better in our field. Okay, 4 stars. So we just saw the Marimekko chart. This one is also a Marimekko chart, but it has an added dimension. So this is a 3D Marimekko chart. You just break up the parts of the chart according to another dimension. Adding a dimension in a lot of cases will lead to Xenographics. This is Hans Rosling, and he did a very good job in popularizing the bubble chart. He didn't invent the bubble chart. He actually reinvented it, and reinventions are quite common in data visualization. And they are responsible for a great part for the multiple names that charts sometimes have. But I wanted to talk about the bubble chart. An animated bubble chart has 6 dimensions. And what Hans did was using a scatter plot and just adding dimensions to it, the color, the size, and also the animation. So adding dimensions is a nice technique. I really like this technique of mapping another dimension to the width of a line, and then you end up with something like this. I'm really wondering why it's not used more, because in some cases it can really tell a story. This chart was made by Lázaro Gamio from Axios, and I asked him about the weird charts they make, because they make a lot of them. And he explained to me that they have this rule that a story should only have 1 visualization. So they try to pack as much into their visualizations as possible, because they only make 1. And he's saying that design constraints leads them to produce good weirdness. So yeah, I obviously I like that very much. And then he comes up with things like this. So this is a map of emojis. This technique is called Chernoff faces. And Chernoff faces are icons where you can map a lot of data to. So there's data encoded in the color skin. There's data encoded into the shape of the mouth. There's data encoded into the bags below the eyes. So there are a lot of dimensions visualized here. And you can take this technique, it's actually called glyphs. So these icons where you map a lot of data to, they're called glyphs. And this is a glyph taken from a study about semen analysis. And if you count them, there are 20 dimensions put into a single glyph. So that's quite impressive. They use this to compare the semen of different animals. So you have here, this is the human average, grade A, B, C, and D. I hope I'm a grade A human, but I'm not sure. There's a sperm whale, of course. If you do a study on semen analysis, you have to have a sperm whale. And then my favorite, the rat on drugs. But we all know who the best glyph designers are, right? It's the Italians. They have a certain type, a style of database, where they just take the database and then map every dimension in the database to these beautiful glyphs. Yeah, I like them very much. They're very beautiful. But in terms of communicating data, I think if you use glyphs with a lot of data, you run into trouble. So adding dimensions will lead to weird charts. And then it's just a matter of seeing whether this technique, whether this new visualization you come up with works or not. So this is Jorge Camus, the inventor of the drunken speedometer. And in his book, he says that every new chart type should be met by a healthy amount of both enthusiasm and skepticism. And I think I'm a bit too much on the enthusiastic side, but I think also a lot of people are too much on the skeptic side. And then there's Michael Correll from Tableau, and he wrote a hilarious paper on how to kill bad ideas in visualization. Sometimes there are innovations, new chart types, and sometimes you can immediately see, well, this is a very bad idea, we shouldn't do that. But then it gets popular and other people copy it, and yeah, how can we prevent this from happening? So what Michael did was inventing a new visualization. This is not a drawing, so there's data encoded in there. And he invented the Ross-Chernoff glyphs. And as he's saying himself, well, Ross-Chernoff glyph most likely to use a term of art suck. But how can we prevent the further spreading of this new visualization? And it's actually a bit ironic, but because he put the code on GitHub, so anyone can use the code and make charts like this. And Playfair also already knew it. So he's saying that here that we need to produce novelty, we need to be innovative, but in the end, we need to aim at facilitating the communication of information. Okay, 5 stars, last one. So this is the Minard map again. And what Minard did was marrying geography and flow data. So he made a map of the flow. And in the days of Minard and Playfair, a lot of data was geographic data. Playfair was especially interested in time series. And the flow is just a connection between two locations. So we can categorize the Minard map over there. Today, if we want to make the flow visible on a map, there are other techniques, and this is one of my favorite Xenographics I found during my research. It's called the ODMap, invented by Joe Wood, who is also a speaker at this conference. And it's like a map of small multiples. It's like a kind of fractal map. And if you can wrap your head around it, it's really effective in showing the flow of things. So I really invite you to check it out. It's a very interesting technique. But of course, today we have other kinds of data. We have a lot of graph data, we have hierarchy, and then we also have statistical information about our data. So we know about uncertainty, distributions, and correlations. So I tried to come up with an example of all these crossings. And some of these are pretty obvious. So a map of the network is like a tube map. But this, for example, a map of time. This is interesting. It's called a temporal cartogram. So you morph the geography, and the distances are travel time. So not real distance anymore, but travel time. And this actually is a technique that was pioneered here in France as well, already in the 19th century. The link is on the site. So I think you can see where this is going. So we make a matrix, and then I try to come up with a visualization of all these different kinds of data aspects, so to speak, semantics and statistics. And this worked quite well. And I'm not sure how much time I still have left. But then I thought, well, there are still a lot of blanks, but I think with my website, I can fill in all the blanks in this matrix, but it was a bit harder than I thought. So there's still a lot blank in this table. It's live on my site, so it's a work in progress. And I think this can be a tool for people that have a certain data at hand that has two of these aspects that are in the matrix, so they can go to this matrix and find a technique to visualize their data. And for me, it's a great technique to go hunt for new xenographics. For example, I was wondering, can I find something that visualizes the time or the evolution of a hierarchy? And then I found this one. So they're all links. Oh no, sorry. As I said, it's a work in progress. It's called Treeflow, developed by Jeffrey here, who is also present here. So crossbreeding data aspects, mixing different kind of data semantics with statistics can lead to great xenographics. And in doing this research, I noticed that the gap between the practice, where I come from, and the research, it's actually a quite deep gap, because I'm interested in new visualization types, but during my research, I found a lot of interesting stuff I didn't know before. So the gap exists, and it's a bit of a problem for the advancements of our field. So I talked with Till Nagel from the University of Potsdam, who is also present here, about this, and he gave me 4 kind of solutions. And he said researchers should not only just publish papers, they should popularize their work. There's a link to an article on how you can do it. The practitioners should read the papers, so that's what I'm going to do from now on. The tool builders should implement new techniques that have proven to be efficient in some sense. I think raw graphs is an excellent example of that. And then you have the in-betweeners, people with a foot in both worlds. They should step up and really be the bridge between these two worlds. And I think the guys from Data Wrapper and also the women, of course, are doing an excellent job in applying what's been researched into their tool. So I think with this we can try to bridge the gap between the research and the practice. So these were the 5 techniques and 5 discussions I think we need to have if we want to be innovative with data visualization in our field. So I would like to thank all these people who helped me find examples and also helped me in ordering my thoughts a bit. And that's it. You can find my slides online. Every image should be a link to the source. I need to check if that's the case. The site is at xeno.graphics, and there's also a submit link. So if you have a weird looking chart, you can send it my way, and then I can add it to the collection, or maybe not. And there's also a Twitter handle, and I'm also not sure what to do with it. But yeah, as said, it's a work in progress. And so thank you very much for your attention.